Well, so for our next speaker, please introduce Stephen Saidani at UNiDAYS with the talk titled How to Create a Product Catalog Using AI at UNiDAYS. So Stephen studied physics at Nottingham University, and for the last 11 years has been working as a data scientist at UNiDAYS, working in all areas of business from fraud to recommendations. So please give him a warm welcome.
Hello, thank you for coming to the talk. And secondly, I do apologise, this is quite a word-heavy presentation, but it's quite difficult to create a non-word picture presentation when you're trying to extract information from text. So the next thing is, I'm going to cover a lot of topics in this talk, and at the end of the talk there's a load of QR codes which will give you links and further information if you choose to go on and look at those. So yeah, the talk's on how to create a product catalog using AI, and yeah, we'll get into it. So a bit of an agenda there on so we're going to start off with who UNiDAYS are for some of you if you aren't students. Then we're going to start looking at the data, and then we're going to sort of go into the phases of the project and how we work through and solve all these problems. So a bit of overview. So my aims of this talk is going to be to sort of take you on the journey of how we built these systems and solve the problems of turning unstructured data, product data, into useful structured data. I want to highlight the importance of the pre-processing of the data before we started getting into the AI and extracting the data. I mean, you'll see as we go through the talk, the data that we started out with is pretty horrendous. We had to do a lot of cleaning and processing and make sure it was good before we started doing anything. And then finally, I want to highlight the importance of simplicity and not just using AI. I think it's an important thing as a data scientist is to not be able to just build these machine learning models and AI models, but also know when not to use them and take a simpler approach that you will get just as good, if not better, results out of, and not just using AI for the sake of using AI or going in and trying LLMs just because they're the new fancy thing, when much simpler approaches will give you just as good results. So, who are UNiDAYS? So, we're the world's largest student affinity network, powering the next generation of learning and earning for Gen Z and whatever we're calling the next generation, I don't know yet. Our verification technology allows us to confirm the identity of students across 115 regions. So that's the main central point of our business is we can identify people as students. We can use sort of many different techniques. We can log into their portals. We understand and have a whole catalogue of information around institution email addresses. We can do things with IP addresses. And many other technologies that allow us to support institutions and confirm that people are students. And we currently support around 29 million members. I only found that out today. I had to change the slide while I was downstairs. So one of the main features of our platform is the fact that we provide discounts to our users. Through which they allow them to gain discounts with over 800 brands globally. So I mean, you can see some of them there. We work largely with Nike, Adidas, heavily with Apple. And not only can the users come to our platform and gain the discounts themselves, but these partners also can embed our verification technology in their site itself. So, I mean, I don't know if any of you have gone to do Apple Music or Apple Education. I mean, you go and verify and confirm that you're a student. All of that technology behind that is actually UNiDAYS. We're supporting Apple, same with Samsung and things like that. It's obviously white label, so it's giving it to them, but the underpinning technology is ours. So the point of this is to actually look at the purchase data. So when a member of UNiDAYS either uses a discount through one of the partner sites or directly with us, the partner will then provide us back some information about that purchase. So here's some examples here. So the order value, discount value, country, purchase time, product data, user ID, discount code, and currency, along with a host of other things. And the main thing that we actually cared about for this project was the product data, so information on someone bought Wrangler jeans, size 10, things like that. So when the partners or the brands provide us back this data, it has to go through several steps. So they're processing their data in their own way, and they're providing it to central systems called affiliate networks, which are then again processing their data. We're then collecting that data from the affiliate networks, and we're doing a load of processing on it, and then finally storing it in our data stores. We use AWS, so it's S3 and Redshift mainly that we're using, along with a host of other things. So, because we've got all of these steps and things that are causing processing, there tends to be a lot of problems with this data. So each brand's processing their data in their own way, they're causing their own encoding, they're structuring it in their own way. Once that then gets to the affiliate network, they're then doing a load of their own processing on that, altering it, changing it to structure in their own way. And then finally, when we get it, well, I mean, we don't do a lot with it after that point, well, until now. But yeah, so this results in potentially a lot of problems. And a lot of the ones that we did notice were that the data could be encoded in multiple different ways, multiple different types. People are using several different formats, which makes it very difficult for us to then be able to start using it. So this was the first step of which we had to try and solve, was how do we then take this data so that it's all in a standard format so that we can then start doing something with it. Here's a couple of examples of some text strings that we actually get back from it. As you can see, they're pretty horrendous. I mean, this top one here is in a completely different language, and it's got several encoding problems. Same one at the bottom there. I mean, I'm sure you can see there's some correlation to the actual cleaning of it afterwards. And then some companies using abbreviations for their own things as well. So MyProtein, just calling everything MP, doesn't particularly map well when we're trying to do expansive text analysis. So we had to solve this problem, and we had to solve it on a general scale for everybody. So we then go into the phase one of this project, which was trying to resolve all of this. So the aim of the first part of this project was to build a solution to address the problems with the data and standardize it so that we could extract the information from the product data later down the line. So how did we go about doing this? Firstly, we had to deal with all of the encoding. So there was two main problems in that. Is URL encoding. I honestly don't know why some of these brands were actually URL encoding text strings and providing it to us, because they weren't in URLs, but they were doing this. Just for anybody who doesn't know what URL encoding is, it's transforming certain characters to allow it to be transmitted across the internet. So you'll see some weird characters when you're looking in URLs, making it easier and better so that they actually can be transferred across the internet. So firstly, we had to resolve that problem. Now that was pretty easy because there's a lot of fairly standardized libraries to solve that. I think I wrote all of this in Python, so I think I use HTML and URL-lib, I think were the two that we eventually solved the problem with. And then the next one, which was far, far more complex, was converting everything to UTF-8. So again, if you don't know what if you don't know what encoding is, then there's a link at the end for that. But basically, we should be ideally using everything in UTF-8, but they were translating, bringing it in many, many, many different ways. So what we ended up doing was trying to identify the most common ones and deal with like 90% of the problem, and then eventually just cycle through until we actually got a solution which actually outputted into a decent format. So the next part of it was to resolve the language problem. So as I say, some of it came in German, some of it came in French. Largely we didn't get any of the non-Latin languages, which was kind of lucky because I really didn't want to deal with that. So how did we go about resolving that? As I said, UNiDAYS is built on AWS. So rather than try to build our own language translation model, because that would be ridiculous and difficult and take a long time, especially when there's models out there already, is that we just use Amazon's translation service. So they have a service which essentially you can plug in a language, you can plug in some text, and then you plug in an output language, and it'll just convert it for you. Now, there is a problem with Amazon's translation service compared to things like Google's, is that Google will often detect the language for you, whereas Amazon's doesn't. So we had to go find out and actually detect what the language was. So we used a library called, or a model called CLD3, which again was developed by Google, and most of you will probably be using it in some format, some way. I think it's embedded for offline translations in Chrome, so it's going to be on your computer somewhere, and you're going to be using it. But we had to directly provide some text and actually use it as a service rather than something that's embedded just within your computer. So once we were able to detect the language, we were then able to input it and actually get some English out, which was great. So we're now in a position where we can actually start doing something with the data. So I just want to reiterate, we can see how bad this was to start with, and making that pre-processing and ensuring that your data is good before you go on and doing all the ML and the data extraction is very important. I mean, I know there's a phrase in data science, and pardon my English, is shit in, shit out. If you put in rubbish in, you're going to get rubbish out. So the next one was to go on to phase 2, which was how to actually extract this data and actually how to get information out. So the aim of the second part of the project was to build a solution that extracted the useful information, which in this case is called entities, out of the product strings. So we identified 15 that we would want to actually take out. Age category, which is like child, adult, junior, bra size, brand, color, flavor, gender, length, dimension, numerical size, quantity, shoe size, size itself, so small, medium, large, trouser size, volume, and weight. On a side note, I had to learn a lot about different clothing sizes. I honestly didn't know anything about bra sizes before I started this, and I had to learn a lot about it, along with why trouser sizes are, for males, are done in different to how trouser sizes are done for males. I don't know why we can't all have standardization, but hey-ho, here we are. So how did we go about doing this? So we used a technique called named entity recognition, which is a subset of natural language processing. So it's looked to extract entities out of the text. So in this example here, we've got ousted WeWork founder Adam Newman listed his Manhattan penthouse for $37.5 million. So as we can see here, the organization is WeWorks, Adam Newman is person, Manhattan is location, and monetary value is obviously 37.5 million. So that's what we wanted to try and do, but for a very custom set of data that's ours. So how did we go about doing this? So we actually tested and looked at, a lot of different types of models. Again, because we were trying to do a very custom set of things, it meant that we had to do a lot of fine-tuning and custom training. So what that means is we can't just use the out-of-the-box models. We have to really train them and define them on the unspecific problem that we're trying to resolve, which you will often get better results. I mean, I did initially plug it into just the standard models, and it really didn't give very good results. So we looked at 3 sets of models. So LLMs, which I think you're all fairly familiar with, which is GPT and Llama 2. However, they did give very good accurate results, but they cost a lot to train, and they cost a lot to maintain. So we simply, for the increase in accuracy, we opted not to use them. I say at the end of the day, most of us work in business, and we're here to make money. If I'm then costing the business more money to train it versus I can do something cheaper, which is almost as good, then I might as well go with that. So BERT, which I think was talked about a lot in the last talk, so bidirectional representation for transformers, are language models, again, developed by Google, and these were the models that we ideally eventually went with. And then the final one is Spacey, which is an open source NLP library. It gave some decent results, but as I say, at the end of the day, we actually went with BERT. So how did we go and custom train these? How did we go and make this BERT model actually do what we wanted it to do for our specific case? So we had to go and do a load of tagging, which was incredibly laborious. We had most of our analytics team, me, a couple of our data engineering team all sat there just going through data, tagging it, because we wanted to ensure that the data that we were using was correct and decent before we went on. So an example here is of one of the strings that we've got was Night Guardian 2 goalkeeper jersey, men, black, medium. So I mean, it's quite difficult to just look at that, but we'd obviously then tagged brand, gender, color, and size, and then stored on that. Now, not all of these entities, as I say, we identified the 15 entities at the start, not all of these entities were contained in every data point. And then finally, any text that couldn't be tagged was just assumed to be the product itself. So again, in this one is Guardian 2 goalkeeper jersey. That's the actual product itself, and not some metadata associated with the product. So once we'd done all of that, we're then going to use the BERT model. Now this actually has its own form of custom tagging that you require, which is called IOB, or inside, outside, beginning format. So what this means is that for any word that's at the start that is not an entity, you are tagging as an outside, so you tag it with an O. At the beginning is the start of any entity. So if you have one word or you have multiple words contained in an entity, you start, the first word in that is tagged as the beginning, and then anything subsequently of multiple words in your entity is considered inside. So here's an example at the bottom. So you've got Balenciaga, triple S, training white 437. Now, so any of the vigilant of you will notice that I've actually got more tags in there than actual words, and that's because you also have to separate out punctuation. So in this case, we're actually having to separate out the parentheses into their own tags, because they do represent the shoe size, but they're not considered part of the number. Okay, so let's just try, I don't think there was a lot of what on BERT in the previous talk, so we'll just quickly go over what BERT is. So BERT, which is, again, bi-directional encoded representation for transformers, really difficult to keep saying that, is based on transformers, a deep learning model, which every element is connected to every other input element, and the weights between them are dynamically calculated based on the connections. So this was actually really good, because what it meant is that it works on context. It doesn't just go and try and extract one word or try and predict one word, but tries and predicts the word based on all of the other words in your text or your sentence. So in these cases for us, it was actually really good, because for often we had things like S for small in size, but you could also just have comma S, which was plural. And so given the fact that it looked contextually at the whole sentence, it meant that it wouldn't, because there was a comma before it, it wouldn't just represent S as S. There's several layers to how BERT actually works. Again, I won't go into much detail on all of these, but if you want to look at the paper, I think one of the links at the end is the paper, so you can go and have a read of that. So after we'd trained this and done all the hyperparameter tuning, our model actually turned out to be 92% accurate overall. So it turned out to be really good for actually predicting the entities contained within our product strings. With some variation in each individual entity. That was mainly due to the fact that we had such small sets of data specific to each entities. There wasn't a lot of information about bra size and I think a couple of others I can't remember. So once we built all of this model, we then started to go, right, we're going to start using it. However, we actually chose not to use it for every entity. So we only, I think it was only 10 of the 15 entities we chose to use it for. And this way it comes into the final point I made one at the start, is the point on simplicity. And this is because for the others, we went on a rule-based system. So the 5 categories we actually went on a rule-based system for were age category, gender, length dimension, volume, and weight. And this is because these are fairly standardized. I mean, so for age category, there's only about 5. The world's not going to alter the way that we measure volume. There's about 3 or 4 different standardized unit measurements. The same with weight. So it meant that we could just create a simple set of rules that would just constantly extract those out and would always be 100% accurate, whereas the model may miss some of that information and not do as a good job. So here's an example at the bottom of like the rules we made for weight, which is it's always going to be a number, then there's potentially going to be a dot, then another set of numbers, and then some units. It's always going to be that way. So yeah, so we went on and built a rule-based system around that, which sat on top of the model afterwards. So then finally what we did before we started outputting all of this data was we actually standardized a lot of the outputs. So for age, we always ensured it was in years, because some people sometimes put in months, especially when you're looking at baby things. Length dimensions now. I'm metric, so anybody who's going to do anything else, have an argument with me. We're not even discussing that, so always in meters. Volume always in milliliters, and weight always in kilograms. Now, we did try to do shoe size, and here's where my deep understanding of shoe sizes now come in, and the research that I had to do, is that it's actually really difficult to map one shoe size to the other, mainly because of the shoe sizes here. You have male shoe sizes, you have female shoe sizes. They don't map ideally or perfectly to EU shoe sizes, which is a nice long standard scale. So we ended up giving up on that and just outputting the scale that we wish to have for that shoe size. So here's some examples of the clean product strings, then my model outputs, and then finally the outputs of the whole system itself. So as you can see in the top one here, the model itself did a pretty good job of extracting the data perfectly out. So it took the brand, we got the gender, we got the color, and then we got the size out of there. So as you'll notice, even though it says large there, we do actually convert that into S, M, and L with XL and things on top of that. To ensure that the standardization, it means that our analysts and our systems will be able to easily define and understand all of that. Again, in the second one here, you can see a nice example of the inside-outside output, beginning inside output there with Under Armour as the brand, and then just the only other thing in there is women's, and then the rest is just the actual product. Now, the final one at the bottom here, you can see that the model actually hasn't done a particularly good job at extracting all of the information. I mean, it's got the brand, it's got part of the weight, it's only got the 3, and then it's only got 2 parts of the volume, but it's also considering there's 2 separate volumes in there because it's not considering the decimal point there particularly well. So that's actually not very good for what we wanted to do. However, because we then went and actually used the rules and the extraction rules on top of that, we were able to actually get a decent result out of that. So this comes back to actually using the simplicity and ensuring that using the best tool for the job. The model there isn't good enough to solve it, or it isn't considering maybe over time when we retrain it, it'll improve, but right now it's not good. But whereas if I've just done the rule-based stuff, actually gives me 100% accurate. So, in summary, basically we obviously built all of this system, and then we provided it as a service to our data engineers. And now what they can then do is they can then just push the data through whenever they like. It'll give them an output, they can store it, and they can then store it in any way, and then the analyst can start using it. Our systems can then start feeding back into our systems. I mean, I think it did such a good job that we ended up directly feeding it back into our search. Because previously our search was just based on brands, so you could only look at brands. But now you can start looking at products. You can go like Nike Air Jordans, and our search text will now understand it and go, well, that's associated with Nike. We'll now take you to the Nike discount. So the other thing is here's a full representational diagram of how the whole process worked, from the input to us using the Amazon translation service with the detection and some abbreviation rules. Then our split out of our base NER system and our model-based extraction rules. Then we've got our standardization, structured output, and then stored in our S3 and then our data warehouse, and then our systems and our data engineers can do what they like with it. At this point, I don't care. So what are we going to go on and do next with this? is we're actually going to start, well, no, this was the second phase of that. What we want to now go and do is start to categorize this information and start to extract and go, right, okay, so even though it says Nike Air Jordans, it's like, well, they're actually trainers. So how do we go about doing that? I think we're going to start building on what we've got previously and try and use more NER along with a load of other techniques to try and improve what we've done. So here's the links to anything that all of the stuff that I've talked about here, say more in depth. So you've got all of the stuff in encoding if you don't know what encoding is. NER explained in quite depth. That's the model that's the BERT model paper. That's information on your Spacey library. That's the CL3 detection language, AWS translation service, and regex. If you haven't got a reason to use regex, don't use it. It's horrendous. But if you need to use it, then there are times and places in which you need to use it because it does do a great job. But it can get horrendously massive, horrendously tricky, and incredibly, incredibly difficult to debug. So, yeah. So, thank you.
You mentioned a 92% accuracy on the NER.
90, yeah.
What do you do with the 8% that sort of escapes that process?
So right now, it's just going into the system. We're just accepting failure on it. This is literally the first trial phase of this. So we're hopefully, we're going, I think I've got it set for September, we're going to go for a retrain of the whole system and actually try and see and improve on that. And then at that point, we will probably look to try and deal with some of the failures. However, the problem is you don't, unless you're looking at it visually, it's quite difficult to determine what is a failure and what is the success. I say that last example I had at the bottom there, where it didn't particularly extract the measurements very well. If that's just outputting, without looking at the texturing, it probably would have looked like decent, normal things. So, yeah, it's a bit difficult to determine that. So, and we're kind of undecided on what we're going to do at the minute. If it fails right now, it fails. But this was just the first. Beyond prototyping now, it's in production, but we were looking at doing it there.
Thank you.
Yeah, very interesting talk. Thank you. Two questions. One is kind of like, what is the kind of like the angle of this model? As in, sort of like, is there any sort of like commercial plan or project to sort of like to modelize this?
So yeah. You mean commercial models of what we're going to use with the output, yes?
Yeah.
Yeah, okay, so the first one, the biggest one was we put it straight back into our search. So allowing people to search for products rather than just brands, which was previously. We are going to look at adding this into recommendations, so our recommendation engines, so actually bringing that in and looking at product level things as well, along with stuff with our CRM. So we're going to add it. So it allows us to see, rather than just someone shopped at Nike, they've shopped at Nike and they've bought some shoes, we can then go, oh, you want some shoes? Or if someone's purchased something, a laptop at Apple, for example, we go, well, okay, what additional products could be useful for you to associate to then do that? So that's the sort of things that we're looking at doing with it.
Yeah, awesome. And my sort of like follow-up question is kind of like from a more of an engineer point of view is how do you capture the sort of like get the feedback loop on sort of like your model performance? Because 92% is kind of objectives, and people using could be like, I don't know.
That's a very, very good question. Right now, we're going to have people looking at the data and seeing what's good and what's not. Hopefully, with the retraining, which now that we've got this, will allow us to tag stuff much quicker because the model should hopefully tag stuff. We should get improvement over time. But right now, it's going to be the subject matter experts and the people who understand these products and these brands to actually go, it's doing this correctly, it's doing not doing that correctly.
Yep. Awesome, thank you. And just to be cheeky, why is bra size is important?
It's not. It was just a useful bit of information. Because when we went looking through, like, to say, lots and lots of data, we're like, well, what's useful? I mean, it's just a measurement of something. But like the fact that we know someone is using small-sized clothes, we can then. But there are brands that are catered to smaller people, and we go, right. Well, actually, we'll recommend those things to you rather than that. So it's just a bit of information, more information about our users that we're able to collect, so that we can fine-tune what the journey and the experience they're having on our platform.
I thought you were doing some sort of like pregnancy.
No, I hadn't actually thought about that, but no. I mean, a lot of the other things is because you get a lot of that. We do actually have things to say maternity and things like that. So, but also, I say there's a lot of students, these are young people, so at universities. I mean, let's not carry on down that line.
Over here, please.
Thank you. It was very insightful. It's more related to his question, like from the feedback loop perspective. Was there any? So you did have a human in the loop, right? So did you also have some sort of active learning integrated into it, or?
Not at present. The aim is to collect this data, do regular retraining, and once we're confident, we will then build it into an automated retraining loop. But right now, it will be, because it's such a new product, we want to ensure that we're getting it right. It is a lot of the initial parts of the tagging and the evaluation of the success of the data output, as opposed to like the model success and the model training is going to be human at this point. I mean, we're not going to get them to look at thousands and thousands of things. We're going to obviously sample that and get them to look at small subsets of it. But yeah.
So what did the time scale look like for you?
For this whole project,
Right.
9 months.
Okay.
From end to end, yes.
All right. Thank you.
Hi, thank you for the talk. Just thinking, why did you break down the translation part and the NER bit? Why not use an LLM and then fine-tune it to do both these tasks?
Okay. So it came into LLMs. My thing with LLMs, and I think the guy who talked previously, is that like a lot of people are just using it for the sake of using it, like, and the job, they're fine-tuned to do certain jobs. We also wanted to ensure that the text was clean and decent at the start, and we couldn't then go on and do the other steps within the project later on down the line until we had all the stuff in English, because none of our analysts or our system engineers or anything like speak. I think perhaps we've got a couple of Spanish people in our our engineering team, but most of that is in English, and we needed to ensure that the stuff was all correct before. And it's also splitting of responsibility. Don't build an all-in-company system that does everything. Split your jobs down. Make sure that that's doing that, because then perhaps the LLM changes or alters itself in the future, and it doesn't do exactly what I'm doing there. But if Amazon Web Services translation service changes, I go, well, that bit's breaking, I can alter that bit. So splitting out of responsibility is also equally as important as trying to do that. So.
Thank you.
We have time. I'm going to pass it back here.
Hi, I have a couple of questions. First, when you mentioned that over 5,000 data points were manually tagged, did you explore like any other automated way to do it? I understand it was for the accuracy, but let's say the data was even bigger, then how would you tackle that?
So yes, so we did consider doing this. However, the problem is it's a highly customized thing that we were trying to do. We were trying to tag our own things highly customized and in the way that we wanted to tag them. So we probably could have got some results out of using an automated tagging system, but we wanted to ensure that the data was 100% accurate, or as accurate as it possibly could be, and in the way that we wanted to define it. So we opted not to do that.
Got it. Just one more question. So is this solution already in production?
Yes.
And
yes.
how did you guys do it? Like, are you rolling out, a percentage of, like on a percentage of users, or like everything at once?
Sorry, say that. Sorry, I didn't quite catch the end of that.
What I've been asking, like, your model, are you like using it on all your users, or is it like releasing it only on 20% and checking how it is performing?
No, so it's currently in production on all of our data. So as I said, if we look back to, I can't remember this slide here. If we go back quickly. Sorry. So this is our process for collecting the data on a daily basis, and this runs on a daily basis because all of these systems are aggregated in a different way, and they're only generally updated once a day. Largely, brands are not streaming data into these aggregation services. They usually batch process at the end of a day. So we are processing this once a day. So our data engineering team are providing that data to the service once a day and getting results back and then going and doing something with that. But it is being done on all of our product data that we're getting back.
Got it. Okay. Thank you.
Yeah, thank you for your talk. It was very interesting. I just wanted to know about the multi-language part that you did translate to other languages to English and then processed afterwards. Were there any cases that like English and different languages were in same text? And if you did, and how did you process it?
So yes, but the lucky thing is Amazon Web Service translation model deals with a lot of that. If the text is the same, it'll just output the same thing. Like if it can't find the result, or you're not providing it properly, it will just output the text as it was previously. So the Amazon Web Service dealt with a lot of that for us, which extracted that out, so we didn't have to deal with it, luckily.
So follow up on that part. So did you check like kind of accuracy result out of the Amazon Translate like afterwards, or you just used it?
No, so I mean, obviously we did go through and check and have a look at what it was doing. Yeah, I mean, it did a great job. I mean, they've got papers on this stuff themselves, and you can go and read on that actual service and how that model works itself. I mean, the bigger question was how well we actually detected the language, because if we weren't actually inputting the language correctly, then we'd have a problem. I mean, I think some stuff was coming out from the CLD3 as Afrikaans, and it definitely wasn't Afrikaans. But at those points, we've got to accept either it's probably English, or we're going to have to just deal with that at a later date once the system's a bit more robust.
Thank you.
Amazing. Unfortunately, I know that's the second time. Unfortunately, it's the end of the talk, but love again the idea of simplicity and how from such a huge amount of data we can find that simplicity is still the answer. So thank you very much for that.
No problem.
For everyone else,